Okay, let's look at section 4.6. This section talks about proofs involving Cartesian products of sets. All right, let's recall that definition of A cross B. Right? So Cartesian product of A and B is simply a collection of ordered pair. So say x comma y such that x is from set A and y is from set B. Right? So let's look at an example. Let's say we want to show that the set A cross B intersects C is the same set as A cross B intersect A cross C. Right? So we have to, in order to establish equality, we try to establish mutual containment. So let's try to show that the A cross B intersect C is a subset of A cross B intersect A cross C. Right? So element chasing. Right? We're gonna choose any element. Right? But remember that each element is an ordered pair, so I'm gonna call it x comma y. Right? So this is in set A cross B intersect C. Right? So this means that right, by definition of a Cartesian product, so x has to be in A. Right? We have that. At the same time, y has to be in B intersects C. Alright? Alright, but let's see. So we know that x is in A. And since y is in the intersection of B and C, so y is actually in B. At the same time, y is in C. Alright? So therefore, if you look at the ordered pair x comma y belongs to, right, since x is from A and y is from B, so it's got to be in A cross B, right? And also x comma y belongs to, right, since x is in A and y is in C, so it's got to be in A cross C as well, right? So which means that since this x comma y belongs to both of this set at the same time, so we know that x comma y belongs to the intersection of those two sets. So A cross B intersect A cross C, right? So therefore, we could establish that A cross B intersect C is a subset of A cross B intersect A cross C. Right? Let's show the other containment. All right. Now same way, just the other way around. So we start with choose any element. Oops. And any element x comma y. Right, from A cross B intersect A cross C, right? Which implies that, all right, so since so this means that since it's an intersection, so x comma y is in A cross B, right? At the same time, and right, x comma y is in A cross C, right? Right. This is an and. All right, which means that let's see, x must be in A, right? And y has to be in B, right? At the same time, x is in A, I already wrote that, and the y has to be in C. Right? So since the y is in B and C at the same time, so we can combine that. We know that y is in intersection of B and C. Right? So which means that ordered pair x comma y has to be in A cross B intersect C, right? So therefore, we could establish that A cross B intersect A cross C is a subset of A cross B intersect C, right? So therefore, or hence, because we could establish mutual containment, we have equality A cross B intersect C is equal to A cross B intersect A cross C, right? That's the end of the proof, right? That's it. I hope that this was clear.